listen.
Hello everyone, this is Data Driven Chat, and today I'm very pleased to introduce Alexey Grigorev, who is a lead data scientist at OLX Group in Berlin, Germany. He is also an expert in software engineering, machine learning. He's author of multiple books. So I'm really excited to talk to him today. Hello, Alexey, how are you?
Hello, I'm good. It's my pleasure to be here. Thank you for inviting me.
Thanks a lot. So just to kick off our discussion, can you tell us how did you become interested in software engineering, machine learning? What was your journey towards this profession?
Yeah. So since I was a kid, I was interested in computers, in programming. When I was little, I found an old Soviet book about programming. I didn't have a computer, but it was so interesting for me that I read through this book and I was drawing diagrams. It was so fun. And then at school, I had classes in about programming, and then I decided, okay, this is what I want to study. Eventually, I enrolled in a local university where I studied programming and databases, informational technologies. And after graduating, I started working as a software developer. During studies, I really liked mathematics. I really liked statistics. It was around 2010 when I graduated. And back then, I lived in Russia, and there were not so many jobs that required these kind of skills. So people just usually needed software developers, somebody who can program, but mathematics wasn't really required. So I eventually became a Java developer. I worked for a couple of years as a Java developer. Then I moved to Poland. And around 2012, Coursera became popular. And one of the courses there was a course about machine learning. And this is when I watched it and I understood that this is what I really want to do. So I really liked all the mathematics there. It was so elegant, and the way it was explained, I really wanted to just start applying machine learning. And around that time, I think also companies started to realize that this is something they need. They didn't really know what exactly they wanted, so they just wanted to hire somebody with PhD in mathematics or PhD in some heavy like mathematical area like physics or something like this. So around that time, it was quite difficult to land a job in machine learning. So I decided to get some education to enroll in masters. That was business intelligence for me. So I studied analytics, again, databases, and also machine learning. And then by the time I graduated, I happened to be in Berlin. This is where the program was. And by that time, many companies already realized what they actually need from data scientists, from machine learning. They realized that PhD is not always a must. So it's a nice to have thing, but there are more important things they need from the candidates. And this is where I started working as a data scientist full-time. Yeah, I guess that's a bit long answer, but
No, so it's a really fascinating career. So if looking back at what you've done, I know it's kind of like when I ask this question, the natural answer is usually, oh, it's the next thing I'm doing that excites me. But if you had to pick one most important thing you have done in your career, something you're really proud of, what would that be? And you can only choose things from the past. I mean, I appreciate that, you know, something that you're doing now is probably something you're most proud of. But yeah, if you had to kind of look back and something.
A very difficult question. And when people ask me about this, it's always difficult for me to answer because the most important sounds very important. So like discovering something new, and when I think about my work, okay, I do important things, but I don't cure cancer or something like this. So it's okay, I maybe improved the safety of the platform of the company where I work. It's a good achievement. But I'm not sure if I can call it the most important thing I achieved during my career. So I did a few things at my current place. Maybe I'll tell about this later. But also, if I think about this, I did a few things outside of my day-to-day responsibilities of a data scientist. One was writing a book. I think this was a pretty serious undertaking, and then
Well, so
eventually.
that's sorry to interrupt you, but this is one of my favorite books, and actually I ran an annual competition where we actually give this book as a prize, well, as part of the
Wow,
prize. So,
nice.
so yeah, it's a very nice book. So thank you so much for writing it.
Mhm.
Can you tell us a little bit more about that? So how did you decide to write a book? Because that's not something a lot of practitioners do. I'm an academic, so
Mhm.
obviously all we do is we write papers and books.
Mhm.
That's how our productivity is measured. But I think to take the time to write a book, if you're a practitioner, is something very, very special. So can you tell us a little bit more about that?
Yeah, sure. Um, so I was I really liked keeping my personal blogs where I every now and then occasionally write about something. So I really
Mm-hmm.
liked that thing. Um, so, but it was nothing serious. So I never
Mm-hmm.
really considered writing a book. And then for a publisher, the publisher I eventually published in, I worked as a technical reviewer. So
Mm-hmm.
they would send me books to check and then comment on the content, say what should be improved. I reviewed like 10 books for them.
Mm-hmm.
And then eventually they told me, hey, you're so good at reviewing, maybe how about writing a book? And then
Mm-hmm.
I thought I maybe took a week for me to think about this. Should I really do this? Should I maybe not? And then eventually I agreed to do this.
Mm-hmm.
And then yeah, it was quite a difficult thing to do. So it took a lot of time, but then I liked the process, and then that's why I'm now writing a second book.
Oh, awesome. Okay. When is that coming out?
This is already available, but it's not
Oh,
finished yet.
okay. I see. Mhm.
I can share some details and things with you later.
Oh, awesome. Yeah, that'd be awesome. Thank you so much. So, yeah, kind of moving swiftly on to things you're doing at the moment. So, what are you currently working on? If you can share, I mean, I appreciate that you cannot always
Mhm.
share these things. Can you tell us what are you currently working on apart from the book? And
Mhm.
so what keeps you up at night? What makes you excited?
So I work at OLX. OLX is a platform for online classifieds. So this is a place where you go when you want to sell some stuff you don't need, or a place where you want to buy things, typically used things. So a good example of online classifieds platform is Craigslist. People from UK, if the UK maybe know Gumtree. So this is something analogous to that. So it's a platform for online classifieds. Um, I work. I did a few things there. So one of the projects I worked on there was predicting the quality of images. So when somebody uploads an image, it's not always the best quality. But sellers, people who browse through the catalog on the website, they want to see good images. They want to use these images to decide if they want to contact the seller or not.
Mhm.
And often the problems there are maybe it's too dark or too bright, or the object is not properly placed, things like this. And one of the first projects I worked on was detecting the quality of images. And then if we realize that the picture is too bright, then we can tell the seller that, hey, your picture looks too bright or too blurry. Please do something about this. And this is how you can make a picture better. So that was one of the projects I worked on. The other one was about duplicates. So when people want to get more exposure, perhaps they want to sell faster, they just publish the same item multiple times, and this spams the platform. and for buyers, it's not the most pleasant experience to scroll through all these duplicates. So we, of course, want to remove these duplicates from the platform. Sometimes there are fraudsters, so people who want to take advantage over honest, perhaps naive buyers, and then one of the patterns is they take an ad, copy pictures, and then create the same ad. And then they pretend they are genuine sellers, and then people contact them because they often put very nice, attractive price. So people contact them, then say, yeah, I really like to buy your phone. But they say, yeah, you know, like 10 other people want to buy this phone as well. But if you show that you're really like to show your intention, to prove your intention, let's put some deposit of, I don't know, $100. Then some people do this, and the fraudsters disappear with money. So we want to, of course, not allow this to happen, and to catch this before it happens. And the system I developed was dealing with that. So fighting duplicates on our platform, because
we have currently. Yeah, we currently have a related project at Turing where we are trying to detect wildlife trafficking. So basically, we met these people from anthropology who were just looking at, so they're kind of ecologists, anthropologists who just manually go through eBay and try to say whether, you know, if it's a piece of ivory, is that like a genuine piece of ivory on the picture, or is it a fake one? Because obviously, if it's a genuine one, you know, you can't really sell it. So, so currently we're doing these sorts of things, which is very much kind of in line with what you are doing. So I think it's really fascinating work. So tell us a little bit more about, so as someone who wrote a book, you know, and someone who made this journey into data science. So can you give us some tips to people who want to get into the field? So what is the most important thing to remember when you're trying to get into the field? So how do you not lose focus, because there are so many opportunities, options, and so much information, you know, and information is probably not always good. So how do you filter that?
Yes, so since I started as a Java developer and then transitioned into data science, I can give some tips based on my experience of transitioning. It might not work for everyone, but I think for people who can already program, who are capable programmers, this works really, really great. So I am I think I strongly believe in learning by doing. So this is also the concept I used in the book I'm writing right now. So just think about the problem and then solve it. Instead of going deep into theory, just take a library, find some tutorials online, and then just work through these tutorials and solve this problem. What I see people often do instead, they start taking online courses. Taking a few online courses is fine, but don't overdo this, because there are so many courses on the internet, so much to learn, so much to go through, and it creates a sense of being behind. I remember this myself, experiencing this myself, because there are so many courses. The content in these courses is so different. I have to learn all of this before I can actually do something by hand. Don't let this fool you. I think it's best to start from like high level and then go deep when you need. So for example, take a project, try to solve it. If there is something you don't understand, only then go down and try to understand what's going on, what's not working. A good example is support vector machines. This is one of the models. it's very difficult to understand. So it requires a lot of mathematical background actually to understand. So a few years of calculus and then maybe some like a year of convex optimization. It's really tough to understand.
Right.
And then I had this impression that before I can use it, I really have to understand all the details, how it works. But then when I look at this algorithm, it's super difficult. Like there are some Lagrange multipliers, like variables, like it just made my head spin. And then I thought, I really need to understand what these Lagrange multipliers. I go back to calculus, review it, and then at some point it's just too much. So I think just staying on the right level of abstraction is really helpful. So there are libraries that just implement this algorithm, use them, and then at some point when you really need to go deeper, then go there. The most important thing about applied machine learning is using it to solve real problems. So when the thing you're doing solves business problems, it's fine. But knowing formulas doesn't always solve the business problems. But well, the libraries, the work you do, it solves. Of course, like at some point, knowing theory is important, but in my opinion, practice first, the theory second.
So basically, yeah, I guess the advice is so you need to have a basic understanding of what the algorithm does, right? But probably not go too deep if
yes, exactly.
that's going to take you years.
Yes, and there are so many libraries today. So something you can just take and start using. You don't need to write it from scratch. You just take it. It has good abstractions. It's easy to use. There are many tutorials online. Just take this, try to figure out how to use this library, and then if needed, go deep. And also one other thing, so applied machine learning nowadays is often mostly about data engineering and backend engineering, not about mathematics. So focusing on that is also important, not to forget that. So for example, for people who have maybe more quantitative background and not software engineering background, it often helps to think about this, to remember that applied data science is still software engineering, and not to forget that, and try to at least get some exposure to good engineering practices, because this is what is often important at work, applying these models.
I really like your point about finding an actual practical problem, because yeah, this is what I tend to tell my students, that you can spend hours and hours and hours listening to my lectures or reading something, but you will never learn it unless you start doing. So that's awesome. And you touched in your answer, you touched on business problems. So working working on these types of questions in practice, how do you think data science changed, or to what extent data science and machine learning changed the business practices? So what was the impact of data science on business so far? So do you think that we can talk about actual impact, or are we still talking about potential to do something great to change the business as we know it?
Over the time of my career working as a professional, it's been 10 years. So I remember when I just started as a fresher out of university, and I remember what the job landscape looked like what kind of skills were required. And if I look now, it's pretty different. So right now there are, like, you often go you go to LinkedIn and see things like data scientist, machine learning engineer, data analyst, all this, also data engineer, things that didn't exist 10 years ago at all. So I think this shows that actually company realized that machine learning is good, and all these things around being able to process data, this is really beneficial for the business. That's why we see this reflected in jobs around us. And also, like, there are already classical applications of machine learning, something that you can almost textbook applications. So right now, everybody knows that you can use machine learning for demand forecasting, for improving search, recommendations on the platform, detecting fraud, or some marketing activities like detecting customers who are going to churn or scoring potential leads. So this I already call classic applications because this has been solved so many times. And with machine learning, we can utilize all the data the company has and just solve these classical problems and already observe positive impact on the business. It often makes product better. So I think many companies realize that. Also, one of the things I remember from a few years ago when I was interviewing, when I was looking for a job, is now many companies, even for software engineers, include machine learning as either prerequisite or nice to have. It didn't happen 10 years ago. 10 years ago, machine learning was often just a thing that people studied at university, but then never used. So I think the companies realize the potential, and even big companies like Amazon, they often want usual software engineers, not data scientists, already know machine learning.
Yeah, on that, I just also want to say that to our listeners that Alexey has really cool presentation on how to get hired as a data scientist and software engineer, and he recently made a video as well, which I'm going to also link to this podcast. So if you want to get some actual tips on how to get a job in this domain, please do watch the video. It's really cool. There is a lot of really good practical advice there. So I really want to kind of go a little bit deeper into conversation on the importance of coding. So you already told us how important coding is, but so I'm going to ask you the standard kind of chicken and egg question about Python versus R. So tell me, okay, so let's just imagine we have a person who hasn't done much in terms of coding, maybe has a little bit of math background to start in the field. So where should they start? What should they learn? Should they learn Python? Should they learn R? Or it doesn't really matter what you learn as long as you understand what you're doing. So what would be your advice?
Well, first of all, I think it doesn't really matter what you learn as long as you're enjoying it. But I think Python tends to be more popular nowadays. I think like 80%, 90%. Like if we look at Python versus R, maybe up to 90% of data science practitioners, they use Python and they work versus R. Maybe on data science competitions platforms like Kaggle, it's different. Maybe there is more R. So maybe it's like 60-70% Python and then the rest R. But in real world, I think it's Python tends to win simply because it's easier to productionize models with Python. Because also there are in many companies, there are backend engineers who know Python and don't know R, and then they can help data scientists write more reliable code, create more reliable services. With R, it's still more like things academics would use. I'm not saying it's a bad thing. It's just this is what I see. So it's like maybe MATLAB a few years ago. So this is what R is used for some research, for maybe writing a paper. But when you want to productionize your model, make it possible for other services to use at a company, then Python, in my opinion, is a more useful thing.
It's probably also more scalable, right? It's easier to scale because R is you need you also need the company culture of using R, like you said.
Yes,
so if you don't have that, then it's going to be quite difficult.
Exactly. So finding people who know Python, not necessarily machine learning, but just know Python, is a lot easier than finding people who know R. So that's why many companies tend to prefer Python. This OLX is not an exception. We prefer to use Python. We do have models written in R for historical reasons, but new models, things we create now, they are only in Python.
Okay. So obviously we cannot avoid the topic of COVID-19. So we're all feeling the impact of COVID-19 at the moment. So do you think there is a particular role that data science could play in solving the current crisis? And can you, on your end as a practitioner, can you see any applications where data science could be particularly impactful?
So it's a difficult question, to be honest. So because what I see now on the internet is the amount of noise, information noise is just too much. I think the best thing data scientists can do now is just stay at home and try not to contribute to this amount of noise. Because if you fit an exponential function to data, it doesn't make you doesn't make us epidemiologists. So it doesn't make us experts in this. And then people might, you might arrive at wrong conclusions, something you shouldn't spread on the internet. So I would advise not to do this. And also, like for us as people who now have to stay home and suffer in this lockdown, like for example, when I go to LinkedIn, most of the posts are about this. So I would ask people try not to contribute to this. So maybe try to think about something else and try to do something else. Yes. That said, I think there are people who really know what they are doing. So I hope they find a solution for us. So I'm again not an expert in this. So I'm a person who is working in IT companies, solving standard like IT things like standard applications of machine learning. So of course, I heard things that there are people who use machine learning and artificial intelligence for drug discovery, for predicting how diseases spread. I think this is important work, and I think now people will realize that machine learning is something that epidemiologists and other natural scientists can do and use it more often. And I'm not talking about the current crisis, but what I also observed over last year or so is many natural scientists, they start using machine learning more and more often. So my mother, she's a scientist. She's doing research in ecology, and they are also more and more often using machine learning in their research. I think
we had a couple of I think it was a couple of weeks ago. We had Luisa Orsini on the data-driven chat, and she's a biotechnologist. She does some really exciting work in water quality and biosystems, and it's amazing how much machine learning they use there. I didn't before talking to her, I didn't realize how big this field is really. Yeah.
But for many scientists in these areas, this is something really new, and they have to learn this, at least basics, to be able to stay up to date and also use this in their research. This is the trend I see, and I'm very happy about this, because I think machine learning can indeed bring a lot of benefits in these areas where previously people would use something simple. But now with machine learning, with the tools machine learning gives, I think there will be breakthroughs.
So kind of moving on from a specific topic of COVID, if we look in general at data science and machine learning field, what do you think is the future? What will we see in the next 5 years? What are the trends?
So maybe you saw this Gartner hype cycle diagram. Yes, a few years ago, maybe 2 years ago, I remember seeing a diagram where machine learning was at the peak of the hype. So it was prior to current crisis, of course. It was already 2 years ago, and I think over 2 years it stayed like that because people were excited about machine learning, perhaps too excited, because the expectations of data science and machine learning, sometimes it felt like people expect too much. They expect magic, that they will hire data scientists and then magically the company becomes profitable or something like this. So these companies often were hiring data scientists as an investment. Also companies that realized that what data science is and how to use it, they often hired more people than they needed, like an investment, because they realized that in the next 5 years, maybe we will need these people, let's hire them now. Unfortunately, with the current crisis, this probably will not happen anymore. Many companies will try to reinvest this money and somehow optimize how they spend money. This is sad, of course, because for me, as somebody who is doing machine learning, I would want to see the field continue growing. But I think this is inevitable because of the expectations many people have. What they think that this
So do you
is
think
some
we've
sort of
already
magic.
reached, coming back to your point on about Gartner cycle, do you think we've reached the plateau yet? Or because like we've done actually some research on the use of data science in Formula One, and our conclusion is that it already reached the plateau maybe in 2017 in that industry, but it's a very, very dynamic industry, right? So do you think we are heading towards the plateau? Where are we in this cycle?
So I think when it comes to usual companies, not research, I think perhaps the current crisis will realize that actually we're
slowing
down, exactly.
But don't you think it will be like I'm not sure that will happen, because like one of the things that strikes me is that you know, COVID is essentially it's like a catalyzer, because we were talking about how AI and machine learning will change the way we work, right? We were talking about automation and that some people will lose jobs. So I think COVID is kind of an accelerator of that. So maybe we do need more tech to replace people now, so that we could retrain these people now. So instead of like, you know, having, I don't know, 10-20 years, we now don't have that time. We kind of are looking at a situation when we need to retrain them fast.
So in my opinion, artificial intelligence is not at that level that can solve all our problems. We'll still need a lot of time, and then choose some specific areas and optimize there. And what I was saying is that the expectations that machine learning will solve all these problems, I think it will go away now. And companies will be more not selective, but maybe thoughtful when hiring data scientists. So I think the demand will be slightly less than we have now. Yet there are many classical applications of machine learning, as I said, that already have proven like they are already, everybody knows that they are valuable. I think it will stay. It will not go away. And perhaps machine learning, I already see the trend that it becomes more and more commoditized. So it will be simpler and simpler to use. So perhaps we will need people who will know how to use these tools, not necessarily on deep level, but just know how to use these frameworks and all these clouds with AutoML solutions. And one of the most important skills that I think people should have is how to translate a business problem to machine learning, because AI will not automate that in the nearest future, for sure. So how to, like when somebody comes to you with a problem, how do you to transform this, to phrase this in terms of machine learning? How Do you take
Yeah,
this
how do you
positive
make it
person?
business
Exactly.
problem into a coding
Exactly. So
problem?
this is a very nice skill, and I think people who can do this will be more and more in demand. Because yeah, I think business realizes the potential. That's why many companies were hiring more than they needed. That may stop, but still it will be needed for because companies realize that machine learning is a must in certain areas. Without it, they lose competitiveness.
Awesome. So yeah, so basically, yeah, we need to brush up on our translation skills.
Yes.
And if you're listening to this podcast and you're thinking, how can I get into the field? Well, that's great advice. You know, you should think about potentially being that translator. But of course, that also requires understanding of concepts of machine learning
Yes.
and how they work.
I would also advise to invest into software engineering skills. Because one, you need to be able to translate the problem into machine learning, but then second, you need to also code this, use these libraries that maybe you don't always know all the details, all that happens under the hood. You know that there is some optimization going on, so machine learning algorithm. But being able to plug this to the data that the organization has and then produce output is an important skill, and this is a software engineering skill. So I think it's an important skill to invest into, especially if you're starting your career.
Awesome. So we came almost to the end of the interview, and this is a traditional question that I ask everyone. And normally people have a lot of issues with this one because the question is, if you had to recommend one book and one film, what would these recommendations be? So I guess you have written books. So
Yes. So my book, of course, yeah, no brainer.
but apart from your book, your own book,
Uh-huh.
and yeah, I will give people links to your current book, and if there is, you're saying there is something online on the new book already, the links will be there. So just maybe a book you really enjoyed and the film you really enjoyed that you could recommend.
Sure. So one of the books I think was quite useful for my career as a data scientist and software engineer. It's Designing Data-Intensive Applications. So this is a book about scalability, like how to actually put things in production, in practice, and how to make sure it stays there, it runs there, and doesn't crash. So there are many quite nice concepts of how to design systems. This is, in my opinion, an advanced book. So this is not something you should perhaps read as a beginner. Well, as a beginner, you might still go through the book. There will be some things you don't understand. Perhaps over you will still be useful. But this is something more advanced, maybe for middle level. But I think it's a really great book to make software engineering skills and data engineering skills more solid.
What about the film?
Yeah, film. So maybe a TV show?
Yeah, that's fine.
I really liked Silicon Valley, a TV show from HBO, especially for few first seasons. I worked at a startup, at multiple startups, and then some things were pretty close to my heart when I was watching it. Of course, it's exaggerated in the TV show, but it's amazing how they showed how an IT startup looks like. So it's a really good show. I recommend. It's a comedy, so there is nothing serious, but it's about IT startups. Yeah.
Thank you so much for these great suggestions, Alexey, and thank you so much for talking to me today. It was
My pleasure.
great to have you on Data-Driven Chat. Like I said before, please watch the videos that Alexey produced. I can definitely recommend the book as well. So do read the book if you haven't read it. And I'm looking forward to the second, but I haven't read it yet, but I will, I promise. So thank you so much, Alexey.
Thank you.